light up the brilliance in your kids at school. This is the main theme. Regardless of whether you live in the world, whether it's in the US, North America, Asia, or Europe, there are varying degrees of stress that students has been suffering from. Students worldwide are facing immense pressure and competition through the course of their education because most of us believe that success in education is the key to the success in their career in the future. So from the perspective of lighting industry, would there be anything that we can do to help our kids and students at school? And there were a lot of researches that found that lighting could be a very positive impact on students' well-being and performance at school. And this is going to be something that we can work with. So we looked at research reports from Salford University in UK. There are major components of classroom environment that affect student performance and their academic progress. There are factors like lighting, color, complexity and ownership and flexibility, etc. Air quality, all those kind of things, temperature. Among all of these factors, they found that lighting was the most significant factor that affected the performance of the students there. So here we go. We try to create a new value of lighting by creating new kind of spectral shaping that we can offer through our LEDs in order to first boost up the lighting, boost up the energy of the students at school hours when they work on something, when they study, when they listen to lectures. And also we could create a relaxing lighting spectrum that could help them, make themselves ease at home or for some, relaxing hours. And also help them have better, good sleep at the right time of the day. So here are Samsung's LM302N day and LM302N night, with which we implemented those new type of spectra. Let me begin with energizing lighting solutions. According to a survey result from Korean Pharmaceutical Association, there are a lot of adolescent students to consume like a very high caffeinated energy drink in order to relieve themselves from fatigue, toward of sleepiness and to concentrate more on their study. However, everybody knows that too much caffeine is not good for adolescents. So would there be anything that we can help them with? According to study from government agencies and from academia, that the lighting effect would be maximized when the lighting conditions be set to like a cooler CCTs and bright high brightness in order to boost up the performance of the students as well as for workers work efficiency. The problem here is that the researchers made kind of extreme conditions like 6500 Kelvin, very cool white LED at a pretty high luminance level, like over 700, 800, even 1000 lux. This actually works in boosting up the energy levels and awakeness of those students and workers. The problem is that they are not really visually pleasing. By just spending long time under that high intensity light of very cool color CCT, you might get easily tired. And then, in North America and Europe, there's not really many classroom or offices where you guys use like a 6500 Kelvin lighting at such a high brightness. So I mean, if that's not a practical solution, there should be something more that we can do with our technology. So how about this? So these two rooms are actually the identical room with different light setting, but it's really hard to recognize anything that is different between the left-hand side and right-hand side of those photos. Those are 5,000 Kelvin, 500 lux lighting conditions. So what's different? Is there any trick or something? Well, actually, there's some trick. Even though the lighting conditions just identical in terms of color temperature and brightness, these LED lightings have different spectral component. So as you see from the left-hand side, there are augmented cyan portion of the spectrum, while on the right-hand side, you are just looking at the conventional white LED light spectrum, where you see a deep trough around 480 nanometer. And as long as the blue, green, and red components are balanced, you will see just the same color out of those spectra. What's special about 480 nanometer? As a matter of fact, this wavelength is the most sensitive wavelength for human circadian system. If you expose yourself with the cyan light in a certain illuminance, the light actually gives the signal to your retina, where there are certain group of retinal ganglion cells that are sensitive to light, cyan light, and gives the cue signal to suprachiasmatic nuclei in your brain, which is a time maker of your body. And that time maker governs the secretion of melatonin through pineal gland in your brain as well. So by increasing the cyan portion of the light, you are actually suppressing the melatonin hormone secretion during the daytime. We don't recommend that you should use this during nighttime. But if you make use of this type of new spectrum in a proper way, it'll be a really good thing. Without having to put your lighting condition at an extremely bright or a cool CCT setting. So that's the beauty of this approach. So we like to prove the concept by performing clinical tests. We actually did this clinical test by teaming up with a university in Korea, Kookmin University in Korea. So we set up a special lighting experience room, and we recruited 30 people for this testing. And the whole test lasted almost a year, because we could test only one person at a time. And the person spent 3 days and 2 nights in the testing room once under a certain lighting condition, and goes back home and come back after a week and spend another 3 days and 2 nights in a different setting of lighting. So we compared our human-centric lighting solution, which we call energizing lighting solution, and compared it with a conventional white LED of the same illuminance and same color temperature. As we expected, their melatonin level, we took their saliva samples and measured their melatonin level. And their melatonin level, even during the daytime, has been further suppressed when they were spending time under the energizing lighting solution type of light setting. And what does it to them? What type of benefit they get? So we put them on a test. Here's D2 test. D2 test is a standardized concentration level test. You have a sheet of paper with lots of character Ds with single dots or 2 dots or 3 dots around the D character. And some of the D characters are not really D. They're like some confusing characters like P. So you should be focusing on the test for a pretty prolonged time. And you should keep your focus on crossing out the D with correct 2 dots. All right? So surprisingly enough, when those subjects were under the influence of the energizing lighting solution, they had 3% higher score on the average compared to the case when they were taking this test under normal type of lighting. So in order to make sure, we did another test. This is not a formal type of test, but we gave them Sudoku puzzle test as well. And then, more surprisingly enough, the average score was 10% better when those subjects were taking this Sudoku puzzle test under energizing lighting type of setting. Isn't it great? I mean, if you think 3% is not a big deal, I mean, what about your exam score? 3% makes a difference, and actually it translates into a little bigger gap when it comes to like a performance in science and math. However, just high enough energizing effect is not good enough for a practical lighting component. We have to have higher melatonin suppression capability of light spectrum, which is represented by here Melanopic DER. That's an abbreviation of Melanopic Daylight Efficacy Ratio. And as well as MDR, we need to have fairly good lighting efficacy, lifetime, and color rendering effect, color rendering index, as well as good eye safety. We have created a device that performs well in all these 5 different metrics, which is really essential for becoming a practical lighting component. When it comes to the lighting installation practice, you need some kind of guideline. So we took an example of a well building standard here. And well version 2 dictates that they could give maximum 3 point to a lighting threshold of 218 Melanopic EDI. Here again, Melanopic EDI is Melanopic equivalent of daylight illuminance. Sorry. This is how you measure the efficacy of the lighting condition compared to actually sunlight. So D65, there's D65 standard light source that mimics the sunlight during the daytime. And sunlight during the daytime is very effective in suppressing melatonin. And we are comparing a given spectrum and the brightness of the lighting together with the sunlight. I mean, the D65 standard light source. So, Melanopic EDI is, converting the brightness of the light as a metric of the D65, standard light source. So 218 Melanopic EDI, we should be over that threshold. And here's another tip in, implementing that lighting condition. I mean, this is not about the photopic lux that you are measuring on the work surface in normal cases. This is the vertical illuminance measured on the vertical plane at your eye level. So you should be careful when you talk about the Melanopic EDI. This is not the work surface illuminance. Okay, here's an example. We don't even need to talk about the coolest CCT of like 6500 Kelvin. We'll be playing around like 4000 and 5000 Kelvin lighting. So there's a variety of CCT offerings with regard to this energizing lighting solution, as you see here, from 3000 Kelvin all the way to 65,000 Kelvin. And we'll design a light around 4000 and 5000 Kelvin. So the blue bars are representing LM302N day device, and the gray bars are representing conventional LEDs. And then you will see that, so for example, in order to achieve at least 218 lux Melanopic EDI, I mean, you could pretty much able to do that by making use of LM302N day at the vertical illuminance level at the eye at the eye level, starting from like 300 lux and 350 lux and 400 lux on the graph on the left-hand side. Whereas it'll be really hard to get that level by just making use of conventional LED. So you have to use pretty high luminance level there. I mean, 350 lux at your eye level is barely making it to 218 with the conventional LED, and it'll be safe to use at least 400 lux. And it'll be easier if you go to 5,000 Kelvin, but there you can still use at least 300 lux of lighting illuminance on the vertical plane if you just stick to the conventional LED, while you can achieve that level with only like a 250 lux of vertical illuminance using LM302 day, which means that you have wider design space. You don't necessarily have to put the CCT to the extreme end, or you don't have to make it too bright to make a glare on your eyes. Or what about the energy saving? You don't want to just increase the electricity bill by 20-30%, sticking to conventional type of LED lighting and try to boost up the awakeness of the people in the dead space. So here's the smarter way to do that. All right. This is good, and we are good to go to the next topic of relaxing lighting solution. Let me tell you something. When it comes to education, we are talking about kids, young kids and adolescents. I mean, they have eyes with much clearer lenses, and they are much more sensitive to blue light, especially at night. I mean, excessive blue light can cause disturbance to their natural circadian rhythm, and it'll be also even more problematic if elderly people like parents and grandparents share the same space with their kids. I mean, the elderly people has yellowed lenses, and they want like a cooler and brighter light in order to secure visual clarity. But at the same time, I mean, those lighting conditions could be too bright for the kids who share the same space. There are studies on the health consequences and learning abilities of lighting. So starting from the obesity kind of thing, I mean, some overweight people, and there are some obese people, and there are some correlation with the type of social jet lag and those kind of obesity here. So it's a research from Vita Group, published in Current Biology in 2012. They actually measure the correlation. I mean, by social jet lag, we mean that the time difference between the time the person go to bed during work days and the time to go to bed during weekends. So larger social jet lag means that the person are spending more time at night during weekends. And then there's not really clear correlation when the social jet lag is minimal, like 0 to like 2-3 hours. The overweightness and the social jet lag doesn't really show a clear correlation. But if you go further down to like 3 hours to 5 hours of social jet lag, there's a clear correlation between that social jet lag and the obesity, as represented here as BMI. Another thing that we might like to take into consideration is that the academic performance is also correlated with their sleep habit. This is a research published by Zerbini Group. It's a study done in Dutch school. they analyze the academic performance of students as a function of their chronotype. Chronotype means their natural habit of going to sleep. So chronotype here on the x-axis is kind of in the middle of their sleep cycle. So, higher number of chronotype means that the students are like night owls rather than early bird. And you might think that some of the students who study late, so night owls, might achieve better performance at school, at exams. The study just tells the opposite case. Night owls performed worse, especially at scientific subjects like biology, chemistry, and mathematics. Why is that? I mean, there are a lot of supporting researches on the learning capabilities and efficiency correlated with sleep habits. I mean, if you go to bed late and if you lose your sleep, I mean, it's highly likely that you miss some of the deep sleep cycles. And then those deep sleep cycles are what actually helps to consolidate your short-term memory into long-term memory. So by losing that deep sleep cycle, it's not really likely that you perform better at school in the long term. So I think that's the message that this research is giving us. So for students who like to study late, read books at late time, I mean, we would recommend not to disturb their circadian rhythm or natural biological time too much. So, but at least they need some light to work on something, right? They need some brightness. Otherwise, it'll be really difficult to do anything. So we have a solution for that. By minimizing the cyan component, the spectrum of the lighting, actually you can create a bright enough lighting condition that doesn't really disturb much your natural biological rhythm at night. So again, we try to, prove that concept by, also measuring the subject's melatonin level during nighttime. On the left-hand side, you will see that from when measured from 8 p.m. till 3 a.m., the average melatonin level of the subjects were 5% higher when they were, spending time under relaxing lighting solution type of lighting compared to conventional light of the same CCT and same brightness. So what does this do to us? We could analyze the data in more detail. We had to let the subject take some sleep, otherwise it would be really kind of torturing. So we don't have the data points while they are sleeping. So we kind of curve fit in order to have a complete the melanopic melatonin level curve. And then we try to verify if that curve fit was correct by measuring electrocardiogram in situ while they are sleeping. And their heartbeat became slow and slow. And the longest heartbeat interval was achieved at around the same time as the highest melatonin level point. So that proves that our curve fit data is quite dependable. And the scientists defined the 25% of the melatonin level as DOMO, dim light melatonin onset. This is the point of time that we have a phase change from wakefulness to sleepiness. You imagine that there's a person who suffers from, for example, insomnia or any kind of sleep disorder. And you might like to take pills, you might like to do exercise during daytime. I mean, you do everything to get sound sleep. I mean, this is going to be really, really painful if you don't really get good sleep every day. But just by changing the lighting condition in your living room, in your bedroom, you can get a lot of help. I mean, this is an amazing, finding. So we'd like to bring this benefit to our kids as well. I mean, it would be really great. In order to bring this to reality, we have to create components that are practical. So like what I said with regard to the energizing lighting solution, we also analyze 5 different metrics of lighting here: Melanopic DER, efficacy, lifetime, and CRI, and eye safety. And I can assure that the LM302 at night, the energizing lighting solution device, is fairly well designed around these 5 metrics, so that lighting industry should have no problem taking this device into practical installation. So what about the lighting guide? Here I got a very useful guideline from the 2nd International Workshop on Circadian and Neurophysiological Photometry for sleep, evening, and indoor daytime environment. They recommend at most, maximum, 10 lux of melanopic EDI for evening light and under 1 lux MEDI for sleeping. Actually, you don't need any light when you sleep. So it just matters when you do something on like a studying or some reading or something. You might like to have lighting condition that doesn't exceed 10 lux melanopic EDI. 10 lux is pretty low, but I'm not talking about the photopic lux, so you don't need to be worried too much about that. So here are CCT offerings starting from 1800 Kelvin to 4000 Kelvin. And we are going to talk about a couple cases with 2200 Kelvin and 2700 Kelvin here. So we make the orange bar there and gray bar as low as possible to keep that under 10 lux melanopic EDI. And you could easily see that by making use of LM302 at night component, you can achieve lower than 10 lux melanopic EDI in 2200 Kelvin. 2200 Kelvin is kind of amber-like lighting. So if you don't want that amber-like lighting for reading or studying, you might like to just keep a standard bulb color temperature of 2700 Kelvin. And even at 2700 Kelvin, you can brighten up the light condition up to 30 lux by making use of LM302 at night. Vertical illuminance of 30 lux is kind of equivalent to 50 lux on your work surface. And that's pretty much enough to read books and study. While it'll be difficult to achieve that level, you can easily just exceed 10 lux melanopic EDI by just sticking with the conventional white LED of bulb color. So it's difficult just to do that. So by bringing this technology to your home, you can still read books and study during evening and nighttime without necessarily disturbing your circadian rhythm at night. Isn't it great? So to summarize, there must be optimized solutions to create lighting environment that support both learning efficiency as well as healthiness in students' lifestyle. So we recommend those energizing lighting solutions for school spaces like classrooms and gyms and almost everywhere, except some of the spaces where they try to relax, okay? And also, if that's possible, if there's like a freedom of tunability for the teachers, they might switch the lighting condition from one to another, depending on the type of the class, depending on the time of the school hours. They might like to just calm down the kids by turning on the relaxing lighting, by cueing them, by changing the lighting condition. That's something, Professor Mott is going to talk about today.